Afternoon, ladies and gentlemen.
Good afternoon.
All right. After we have a break for the lunch, we are now going to continue for the third material. We have already 460 participants online. Just kidding. Yeah, and so the next material is about the emerging natural infection of non-Laveirania Plasmodium species, the novel tools to understand the malaria infection biology. It will be delivered by Professor Henry. And for the last material, will be guided by our moderator. Acting as the moderator today is Dr. Engineer Martini Engas. She is the lecturer from the Epidemiology and Toxicology Department. So, Dr. Martini, the floor is yours.
Oh, ini berarti ini dia kan belum ya ini berarti ditampilkan.
Good afternoon, all participants. Most of participants offline and also online by Zoom. Okay. In the last session, Professor the name? I see. Yeah. All of this, moderator, yeah. Yeah, as Professor is in hand, yeah. Can I mention your name, Dr. Ed? Yeah,
An.
Dr. Han from National University. Yeah, we'll present about his research of malaria. Yeah. It is the same with my recent research over malaria in endemic malaria in one district in Central Jawa. Yeah, Purworejo. About the mosquito and then the status of resistant status against insecticide. Yeah, doctor, and we as a topic of the research about malaria, genetic, molecular, and molecular biology. Yeah. And then the concept is maybe and want to explain more about this. Yeah. For 45 minutes, yeah, so we can about malaria, about the malaria research, and then discuss session maybe from the audience offline and also can be from the audience online Zoom. Yeah. Beginning. So time is yours. Thank you.
Thank you. Thank you for the introduction. I'm Professor Han. Just simply you can call the Han. It's okay. Yes. Okay. So Yes, I saw the poster in this workshop. I saw my teacher also. That is 10 years old mine. So now I'm a little bit old, but that is me. I would like to apologize if someone may be disappointed. I'm so sorry. Okay. Okay, today, so I'm gonna talk about the zoonotic malaria. Maybe someone is familiar with the zoonotic malaria, but maybe someone is not familiar with them. Because the malaria, we only think about the human malaria, not the monkey or not the rodent malaria. So how zoonotic malaria and human malaria connected? There we can see that one. Okay. 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 The part one. The first part is the background of zoonotic malaria. I give a just title like this: new infectious disease. Because the zoonotic malaria. Just recently we discovered this. Actually, in Plasmodium novae species, the natural host is the monkey malaria, monkey. So we just discovered in 2004. And nowadays, this modified malaria is recognized as a fifth human malaria species. Okay, okay, before that, we have to know what is the malaria. Maybe all of you don't know about this. But if I just simply summarize about malaria, the malaria is human life-threatening disease caused by Plasmodium species. This Plasmodium is a protozoan parasite. That are transmitted to human through a bite of infected female Anopheles mosquitoes. Here is the Anopheles mosquitoes. This vector is red. The WHO annually reports the previous prevalence of malaria case in the world. In 2021, there is 247 million cases are recorded, and within that, 690,000 patient deaths by the malaria infection. So it looks very huge population, but someone cannot feel how much serious this problem. So if I change the word, maybe you can see more. Every 1 second, approximately 8 persons got malaria. So in this section, I have 45-minute presentation. So within this, 90,000 persons got malaria. 19,000 is very huge in the world. And the death rate, if you think about the death rates, every 50 seconds, 1 person dies because of malaria infection. So you can tell more. This is really serious problem. Right? And also recently, from the end of 2019, the COVID-19 outbreak. This COVID-19 is still suffering to overcome this COVID-19, but this COVID-19 pandemic was affected with malaria infection. So let's see, in Indonesia, I just went to Indonesia in recent year after COVID-19 outbreak. So from the incidence of the malaria was increased rapidly. Interestingly, the other species named the traditionally being with Plasmodium falciparum and Plasmodium vivax is major malaria in the world. Other species is quickly increased during COVID-19. So it should be in here included the Plasmodium molletale or other species of Plasmodium malariae or really included here. Anyway, the Indonesia after COVID-19, the malaria case was increased. Actually, in Korea was the same. Korea was increased the case of the malaria. The good thing is, in case of the Korea, we only have the virus than other species. Okay, so let's see this number 3. So here is one question. Do you know how many species of Plasmodium living in the world? How many species? 7. so many, how many?
So like, yeah, so many are still undetected.
Yes, even undetected, and now discovered 250 species. It's a lot. It's a lot. The good thing is cross-modern species have post-selection sensitivity. So now we know only 5 species can infect human. Previously we just recognized 4 species. That is in red color character in here, plasmodium vivax, which are also occurring in South Korea and North Korea also. And Plasmodium malariae, and Plasmodium ovale, and Plasmodium falciparum. And recent year, in 2014, the Plasmodium cynomoldi, actually this species is genotype disease, only can invade, with result of that, only can invade the monkey, especially the old world monkey. But in 2014, we discovered that in the human, we found the Plasmodium cynomoldi. And more recent, just in 2021, there is PDP and INWA, although also the natural host is the old world monkey, but we found in the human. More earlier year, in the 2004, the knowledge-eye, Plasmodium knowledge-eye, also genotype malaria, old world monkey is the natural host, but we found in the human. And now, we recognize this one is also human malaria. Now, and here is the old world, right? And here we found that this species, and here the America is the new world. Here is another evolution of the history in the monkey. The old world monkey evolution and new world monkey evolution history. But in the new world monkey species also have a malaria infection, plasmodium infection. That is Plasmodium simium and Plasmodium brasilianum. And the simium we found in the human in 2017, and brasilianum we found in 2015. So this simium and brasilianum also has different evolutionary history. And also monkey, new world monkey and old world monkey have different evolutionary history. That means the Plasmodium species can adapt to human. This is not just accidentally occurred, it's slowly adapting to the humans. So that is true because we well know that if we see the genetic tree with human with other primate or apes, we know that the chimpanzee only 1% genome of difference, almost the same. Right? Even in gorilla also almost 1% difference. The primate, the old world monkey, only 4% difference in the genome. So this is highly possible that monkey malaria can infect the human. But just previously we just ignored it because of the species specificity. The Plasmodium species has just both specificity, and we just thought that monkey malaria cannot be invaded human. But now the trend will change. The monkey malaria definitely can invade human. So the question is that, so it's really this genotype malaria exists from the past or just recently adapted to human? This is the question. So you can see here the Plasmodium vivax. This is human malaria, and Plasmodium simium we found in the humans. And in here, Plasmodium cynomoldi also we found in the human. But simium is the old monkey as a natural host, and cynomoldi is old monkey as a natural host. So genetically, they are very similar. And when we diagnose the malaria under the microscopy, we see the specific features of the morphology. So when we diagnose the vivax, the key point is from trophoid stage. If the trophoid stage looks like ameboid form, and if they appear with brownish color dot, we just diagnose as a vivax. But how do you think that this simium, as cynomoldi, this parasite also human blood, the still patient blood? So can you differentiate this vivax and another simium or cynomoldi by morphology? Actually, almost impossible. Even the field microscopists, they are experts to differentiate the species. Even they cannot differentiate these species. Just they diagnose as a virus. That is the most problem about genetic malaria. And just recently, we developed this molecular diagnosis method in the PCR or qPCR, something like this. So just recently, we differentiate each species. But in the past, just we thought that this is virus malaria. And so I think that just recently adopted in human, maybe now. It has a long history. So we just misdiagnosed before. Another question is this zoonotic malaria is really like threatening in human? It definitely yes. Because in here, this post-mortem study of the pneumococcal infection is, we can see in the brain picture. The patient died because of the pneumococcal infection, so we can see a lot of hemorrhage, histology in patient blood, in patient brain. But we still don't know the exact mechanism, how this knowledge can make this hemorrhage. Of course, the first can also make this kind of hemorrhage to block in the blood-brain barrier and make this kind of hemorrhage. But it is a particular also kill people with patients, but the age is young age, like children age, no less than 5 years old. But in Norizai, almost the patient, that patient is adult, not a child. So you can guess how much serious problem in the zoonotic malaria. But we don't have any information yet. We just know Norizai can infect human. But how they can kill the human, we don't know. So one study is here from the Sabah, Malaysia. From 2010 to 2017, there is total case of the Plasmodium rosacea is 7,750 during the 7 years. And among that, the total death is 19 patients who died. That is, mortality rate is 0.24%. Actually, this is the same as particle. So we cannot ignore this rosacea infection. So interestingly, in Malaysia, in Sabah, the traditionally developed Parasites and vivax malaria, they were decreased a lot. But Norizai, the novel zoonotic malaria species infection rate was increased. So they not think about the zoonotic malaria. Maybe that is why the infection rate will increase. They just treat and Parasites and vivax maybe. I just don't like that. So this question, is zoonotic malaria is really human life threatening? So the answer is yes, it is. So before we delay, we have to focus on the zoonotic malaria. We don't know the future risk about this. Okay, this is the just map of the drug resistance malaria spreading pattern. So if we just substitute in here the zoonotic malaria spreading pattern, because zoonotic malaria also can adapt to human. The human also travel everywhere. So in the future, we don't know how long time it will take, but in the future, if we are not consider about zoonotic malaria will be spread all over the world. Because even in New World, they are adapted to human naturally. And in the old world also, they are adapted to malaria to human naturally. So this first part, I summarize that we are just beginning to recognize zoonotic malaria from the 2004, from the malaria. And we do not know the exact risk of zoonotic malaria. And just before this slide, I guess this Sabah area is nearby Indonesia, the same island actually. So unless Indonesia has some sort of malaria cases, but that's not clear here. Not only here, so recently it reported in Malaysia, not only Malaysia, also including the Thailand, there are a lot of cases of genetic malaria. So now we just discovered the genetic malaria. Yeah.
The recent study has found that some of the Plasmodium are also in Kalimantan, which is near the Sabah, same island. But this is my curiosity. In Malaysia, we found so many cases there. But in the neighbor country, like in Kalimantan or Indonesia, we found a little bit. I mean, even though we use the PCR, we use the sequencing, and we have collaborated from Australia and also from the US. As I know from my colleagues, we don't really find so many cases like what Malaysian researcher did. So what my curiosity is like, maybe the monkey is slightly different. So that's why all the frequent contact between Malaysian people and Indonesian people might be slightly different. So that's why all the factor also might be slightly different. Or how do you think?
Yes, actually the knowledge side, we still don't know. Human effect passport now.
So what Janet said, Janet is the my former PI. She thinks that the human-to-human cases is not really possible for Plasmodium malaysai. What she found is that the Plasmodium malaysai is transmitted due to animal to humans. So people in Malaysia usually go to the jungle at the night time and stay overnight or even few nights in the jungle and got bited from the jungles. And so Janet and the other team from the UK, actually my team before, we still think that there is no proof, there is no strong evidence for the human to human transmissions. So that's why like the knowledge is very interesting. It's always concentrated to Malaysia territory and not to Indonesia, even not too many in Thailand also. So if you have an idea, then it would be really interesting to see what the point of view of yours.
As I know, in Sabah and Indonesia, there is borderline high mountain area.
Yes, there is slightly.
But when I check about here, has just like land. Check
You mean like the
okay. So if there is a physical barrier like high mountains, that also difficult to access. But if like here, the land area, possibly even the human easily going out. Monkey is no border.
Yeah.
Going out. So we can try to make a spot nearby there, not in the high mountain area.
All right.
So we need to confirm that.
So do you think that the factor is most important part of the knowledge like transmissions rather than the mosquito, the monkeys or the knowledge itself?
I think the monkey in the area because the bacteria, the mosquito, is everywhere.
Yeah.
So we found that the Indonesia has the monkey has 100% immune infection.
Sure. Yeah.
So I thought that Inuit also can get human quite similar with virus. So they can engage humans. So not only molecular case, even other PhD or EMA also engage humans. We have to think about that.
Okay.
So you previously studied in Slovakia, I think. That there has EMA.
Yeah.
And we need really carefully conforming with human also. I know you already tried before, but we have to increase the sample number and the patient number also.
Yeah.
So we cannot ignore that just now. We don't know the future risk of
another my curiosity is that in the factual side, in so, so I want to know your point of view for the mosquito itself. Okay, inside the mosquito, maybe there is some chemicals or some compounds that can support the knowledge or zoonotic plasmodium to grow, then can be transmitted to human. Or what do you think that could be a possible of the mosquito as a factor of the diseases for the zoonotic plasmodium?
I think that inside the plastic, the intermediate jungle and the human that are fully inside. But of course, it has in the package, it has some preference of the monkey or human. But we already found the knowledge in the Malaysia. If human to human transmission is possible, the monkey, the mosquito should be stuck in the monkey blood and they are in the human. So, what's possible? Just vector, which vector in living there,
I'm a little bit like worried that the Plasmodium knowledge can make a good adaptation to all the Anopheles species factors. So if they are successfully adapted to all the factors of the Anopheles, then it would be really like huge of the Plasmodium virus all over the world, because they are successful to adapt to the all mosquito species or Anopheles species, right? Because nowadays it's just like the knowledge is only for Anopheles divers or Anopheles that things. So yeah, so because this knowledge is very adaptive to all the hosts and different factors.
Yeah. So actually, my research field is human parasites.
Yeah,
true. So shall I explain about the molecular way how?
Yeah, that would be really interesting for all the participants.
Okay, so this is my actual research field.
Yeah.
Very, very deep molecular biology. So, this is after lunch. So please don't be sleep.
Okay.
Then listen carefully and trying to understand. I'm trying to explain that easily. And if you don't understand, please just raise your hand. Okay?
Yeah.
So the second chapter. Okay, we cannot stop occurring the zoonotic malaria in the world. So, at least we can use this zoonotic malaria as a virus with those tools. So, how we can use it? Let's see this. Before that, we have to understand the virus. Virus is very special. They prefer to invade young erythrocytes. We call erythrocytes. Okay? And still, we don't have any culture technique for virus. But if we can culture the parasite, like a particle, we can get all of insight from that parasite. Right? If we can culture, we can do it this molecular study or physiology or physical study or drug study, immunological study, and treatment study. But unfortunately, we don't have any technique for virus culture. That is the reason. Firstly, they only get the erythrocyte, one erythrocyte. It's difficult to get that erythrocyte source. Usually, we was trying to culture the virus side. We taken from the cord blood because the cord blood contains a high content of erythrocyte, and we purify that erythrocyte and find culture. But not only our team, other teams, all over the world say, even we supply the erythrocyte in the culture, we cannot go there. We still don't know the reason. No one knows now. So, many people will think about this. Okay, so if we cannot culture the virus parasites, we can alternatively use primate malaria species. So in the 2016, the first modern knowledge is against human erythrocyte culture. So now we can use this culture system and also genetic information. you can just alternately can study or the advance in Asian biology. And most recent year, in 2019, the cynomolgia of culture in the monkey blood. The limitation is still we don't have human blood culture, but at least they can maintain it in the laboratory in the monkey blood. So the previously I showed you that 2002, cynomolgia and biomass is very close in the genetically. So this cynomolgia and this can be useful in human biology, not only in human biology, also blood screening biology. The main thing is that this is not the biomass. And this one can first affect in the monkey blood. So I show you this video. This is video, not a picture. This video is a cynomolgia, what I culture in New Zealand with the monkey blood. So this is hydrogen. This hydrogen rupture after they will engage in new erythrocyte. Okay. Yeah, let's see this video. Okay, they are rupture. So the single measure will release. So
Can you stop, please? Okay, thank you so much, Hassan. Just instructions. Can you explain to our participants how you capture this image or what microscope you're using? Maybe they don't understand what is this microscope? Why he can do like this? Maybe he really interesting to see what the microscope or technology.
Okay, basically without any culture system, obviously we cannot get this kind of video. Right? Yeah. This is in real time. This is detected RBC, now just a rupture. Right? And single nerve rate is released from the detected RBC, the RBC was just breakdown. Right? And this single RBC will invade new erythrocyte. So this is blood stain cycle. So in this video, I took the engagement step and the rupture, how they are engaged to new erythrocyte. Okay, and technically, just culture of the parasites in the laboratory, and we use EVOS by image microscope. It is a simple human.
Yeah. Okay. The student may be interested. Is this microscope same with the light microscope that we use in the laboratory, in our laboratory?
Actually similar, but this microscope developed for the video.
Okay.
Okay. And also resolution is
higher resolution than the light microscope.
Because you know that this melody, single melody size is only 2 micrometers, very small. So clearly see that small melody, the resolution should be high. Okay.
This is from sample landscape. This video, you text from the lab space.
Yeah, the blood from the monkey. Monkey. Because this is cynomolgia, we just have cynomolgia in culture in the monkey blood. So we want the monkey blood and culture.
Do you use plate? Yes. 96 well plate or
96 well plate. Actually, if we want, we can spend more. But if we want, we can spend more.
Yeah.
So, okay, from the rupture, the polymer was released in the present bloodstream. You see, this small merozoid like and one merozoid, this cell, okay, this merozoid is starting to attach to the host cell. And this merozoid also just lost to the new host cell and started to invade. Okay, so they change the original site. Because suddenly other material like minerals go into the RDC, right? So the RDC, the material density is not correct, but they make this kind of original site. Like they are condensed and they use it in short time. So this is the how the metal joint can do to the unimetal blood cell. Okay? So this process finish actually within 2 minutes. The 5 minute process. So one metal joint is basically one REC, they replace it to the several, almost 30 metal joints. And this 30 metal joint can be another new red blood cell. So this metal joint can replicate in the human bodies within a short time. So if we can culture the parasites, we can get this kind of video also, and from this video we can get a lot of insight. Okay, so this is the invasion process of the metal. The invasion process we can divide several steps. Like after rupture of the merozoids, they from single merozoid randomly attach to regular surface. But at this time, with physical force, we can detach this merozoid. It's not a strong binding. But from the reorientation, this stage, after this, the merozoid cannot be detached from the regular cell. They already starting before the cell. So during this, during attachment time, almost 4 things, merozoid 4 things are involved in the merozoid surface protein. So this single merozoid express 8,000 proteins. The small single set 8,000 proteins will not express. It's a lot. Among that, the random attachment step involved in here, MSPs, merozoid surface proteins. And next step, from the reorientation, they use the reticulocyte binding protein, we call EBPs, and reticulocyte binding protein, RBPs.
Okay, interruptions. So why these parasites need or produce proteins? You may explain this to me.
No. Okay.
Why the parasites produce proteins?
Yes.
So they may not know really well why proteins.
All of the living things they produce protein for their survival. Protein is the major material for the functioning of the cell. So to survive this merozoid, single merozoid, they need 8,000 proteins. Every protein has different function, and every protein has different structure also. So this 8,000 proteins just wrap organized well each other, and they make up some complex, and they also interact with the other cell proteins, and they have the function. So if this merozoids want to survive in the course, they should have 8,000 proteins. Okay, so during this invasion step, after reorientation, at this step, actually this merozoids, inside of the merozoid has small organisms we call loctoid and micron. So from here, for invasion step, they release the protein from loctoid and micron. Okay? So they start to invade, and also the surface portion of reagent from the host. Okay? And they are invade, and shortly you saw that the ichnosite, they just condense quickly. And shortly appear this ichnosite pattern, and as well known the new stage, substrate stage, and silent stage, they develop that. Okay, in case of virus, some single have 8,000 proteins, but we just discovered in this table. I calculate this one by one, how many proteins are there? Almost 50. So we know that 0.6% of protein information. Opposite, even in here, you are not really know about this. Just even small, we understand, just in here. So among that, this DDP, PVDVP in the EDPs, PVDVP, and human receptor is a DARC. So DVP plane is the Doppler binding protein, and DARC is Doppler antigen receptor for chemokine. So these two proteins interaction is very important for the successful invasion. So in the laboratory, if we block this interaction, the melody totally is not invaded. So this is a critical protein for melody invasion. Okay, let's see this slide. Here is the merozoite and reticular site. If this merozoite want to invade the mucous reticular site, they should PV, DVP, and DARC interact with each other. And as I told you, if we block this interaction, the merozoite fails to invade the new reticular site. So actually, this is very good vaccine target. Right? If we blocking this DVP interaction, the memory cannot invade to reticular site in the whole system. So actually, the many people trying to develop a vaccine using this DVP protein, but they want to block the DVP. But actually, they are okay because in the field, in the laboratory, if we block the DVP, the vaccine activity is 100%. It's really wonderful vaccine. So in the field, because of the sequence diversity, each patient has different sequence of the DVP. That is why the protection rate is less than 40%. Actually, that's the failed vaccine using this DVP. So this is DRC structure. And this red color subfield, the DVP bind within here, we call FY6 region. So how we can use genotype malaria for malaria research? I explain about that. So here is 5 bucks, right? And we can culture the cynomolgia. Also, we can culture the monozyte. And both of them just recently discovered in the human. They can live in human, right? So actually, this primate plasmodium species share the similar gene, and the similar gene should have a similar function. Okay. So in vivax DVP, we already knew that this is important, critical protein for invasion. And when we're searching in the cynomolgi, there are 2 DVP genes, DVP1 and DVP2. And in the knowledge they have 3 DVP genes. 2 DVP4 and they were expressed with the alpha beta gamma. So today I'm just focusing on the DVP, not other IVP or something other. I'm not focusing on that. For DVP, if we compare each species of DVP and monkey and human DRC interaction, we can get which amino acid residue is important for the interaction. And also we can get some insight of how this primate malaria parasite can adapt to human and can adapt to monkey. Because the DVP is a critical. Okay, this is the methodology. Complex. Okay, so I'm just simply trying to explain about this. So simply we just select the DVP from the PKDVP alpha and P-vivax DVP and P-cynomolgia DVP 1 and 2, and just make a construct of that. And we also select the DRC from the human DRC. The human has 2 DRC types, like A type or B type like this. The FY8 type and FYB type is the human. And then the monkey has 2 isoforms of the DRC. The monkey, I use them here, the macaca fascicularius. Because inside the monkey, we culture the macaca fascicularius. So simply using the mammalian cell, we express that protein. That's simple. Okay? So we can get a protein, single protein. Okay? And I just write here some ELISA, core IP, and octet analysis. You don't need to care. Just this one is we confirm how we confirm this DVP protein and this DRT protein interaction. That's method is like that. So from these results, what we can get? Okay, so we can get the evolutionary history. How do we adapt to human? How do we adapt to monkey? Because now we know the cynomolgi can adapt, and now it adapts in the monkey better than human. And knowledge now we recognize human and monkey, the evasion ability is similar. And virus much adapted in the human. So we know that three species sequence, amino acid sequence, so we can find which residue, which amino acid is important to the cell of the human or monkey. Okay, this is the sequence data, amino acid sequence. So I highlight that this sequence is a system. Why I highlight this system? System can make an isotype bond in the protein structure. Just this system and this system can make a bond and make a bridge. So this protein make a folding. So every system is same in the DBP, in my vaccine and the chemotherapy. That means the same position of the same system, that means all of this protein structure will be similar. That means, again, if the structure is similar, their function is similar. So we know the biological function is bind with human DIC. So quinoliside and cynomolgi DVP also combined with human or monkey DIC because of the system control. And in DIC part, it has, I told you that FI A type and FI B type, which are different in this, in here, and most important part, FI 6 in here. In position 23, there has glutamic acid, but in natural monkey, there are one amino acid released in nature. So, in this part can bind with this DVP protein. If here is deletion, it could affect some binding ability of DVP. That means, if in nature the monkey has some mutation in here, the malaria cannot be made well. Okay, this is also some molecular data here. Okay, this is just a briefly show about our construct. We choose I2. I2 means just region 2. We already knew that this I2, only this I2 domain can bind with the DIC, not other place over here. And this part is DIC FY6. So this I2 and FY6 interact with each other. Okay? So just keep this figure C. And figure D, it shows the protein expression level. Okay, this technique is this page technique. So this blue color band indicates that our protein size. And in this figure, only one band appears. That means our protein is purity is high. Only our protein exists in that color in the solution. So we can simply just mix together the two proteins. Right? So PVDBP mixed with HDS, human DIC. And also PVDBP, also we can mix with MFX macaca fascicularis DIC. And then we confirm how much they are binding each other. Simply that is a full IP method. That small figure. So this is the result of core IP. So simply in this E, column E, if there appear two band, double band, that means they are interacting with each other. Okay? So let's see the result. The bypass DBPI2 with Macacappas pluralis DLC, especially glutamic acid division 1, it cannot be bound with each other. In just normal Macacappas pluralis DLC also cannot be bind each other. But the bypass DBP strongly interact with human DLC. The bypass the bypass can select human as a host, the natural host, because it is most critical for chemical invasion. Okay? And let's see the Piscinomorgia DDP1. There has weak interaction in the glutamic acid deletion 1, and monkey DRs can interact with each other, and even the human DRs can interact with each other. That means the Piscinomorgia naturally can invade human. And in case of this cynomorph, the DVP2, because cynomorph has two DVP, the DVP2 totally cannot bind with the DAS. But actually, this DVP2, we already confirmed that it can bind with molecular density. That means the DVP2 should have different receptor as the DAS. So DVP2 is very important for the engagement. And PKDB alpha also combined with the monkey and human. So we are finding very well. So the P molecular can select as a host human and monkey host. And other protein is CD43 something, and here is PFAD175. This is a negative control. They should not bind with the DS. Okay, another complex slide is here. Very complex slide is here. Okay, sorry, this is microbiology. So this result is from the OPET analysis. Simply, just you can see in this KD equals something number. If this KD value is low, then indicate that these two proteins, DP and DS protein, interact very well. Okay? And if this KD value is high, they do not interact well. Just the result indicate that. So let's see in the PVDP2 with the human DRC, they have KD value 7.7 than 1. It indicates that they are interact very well. In case of the monkey DRC with the PVDP is about 16, 18. And if the glutamic acid deletion is 24 and more, it means it naturally bypass prefer to engage human, not in the monkey. Okay? And how about the PK? The knowledge eye. The knowledge eye has low KD value compared with the bypass, 20, 14, and 22. But they are not different in human and monkey. That means they can engage human and monkey both. So even this graph pattern also we can analyze. In bypass and human DRC graph pattern, they are slowly increase the graph and slowly decrease in this graph. Because we are very long with the bypass DBP with human DRC, they can make a heterodimer pattern. Okay? But in PK, they have just one-to-one binding. They are made complex. That is why they are quickly bind and quickly disappear in that interaction. Because the bypass and knowledge we already know from the previous report. But we want to know in the Piscinomorgia how they are acting. So let's see the Piscinomorgia DBP1 can interact with human DRC with 9.8 nanomole. Of course, they are strongly binding with the monkey, and means they still strongly prefer in the monkey, human. But based on this result, they are possibly infect the humans. So recent results we reported that the cynomolds natural infection rates are increased So this is a molecular, using the molecular technique, we prove that the sign mosaic obviously can relate to human. And the pattern, the binding pattern is like a balance. That's another that. Even the genetically bipartisan sign mosaic more close and more that. So from this result, what we can get? Final conclusion. Finally, we reach the final conclusion. What we can get from this experiment? Okay, we know the sequence of PKDVP, 5-DVP. The amino acid sequence is here, and the PKDVP is here, and cynomosaic DVP1 is here. So the point mutation part is here. The orange part is PKDVP and cynomosaic DVP is the same sequence, but with bilateral difference. That means this orange background of the amino acid indicates that this residue is important to choose monkey as a natural host. Okay? Because monozyte and cynomosaic now adapted in the monkey. And let's see the position of the 281. There is binding, the amino acid, and phenolazide is binding. Only cynomosaic changed out the solution. Right? So this red color background indicates that this point mutation is critical to select monkey as a natural host. Okay? And this yellow background is a position is 363 and 367. This position point mutation will make this one-to-one binding or heterodimer binding. This pattern differentiates because of this amino acid difference. So from the analyze that each species, primate species, and monkey DIC, and cross-conform that each other interaction, we can get which part is which amino acid part is most important to adapt human and to adapt monkey. So if we want to make a vaccine for human, we don't need to care about the all of the amino acid sequence. Just we can point out here the value position at 281. This value is most important to the human. So just we can think about this value, how we can develop this value mutation. Okay? More simply, we can develop a vaccine. Okay? It's so difficult, right? Yeah. So, yeah, the malaria research, the molecular research is really not easy. Even me, it's so difficult. Yes, you me also. So I cannot do alone with my team. So I always make a collaboration with all over the world with a lot of teams here. So in there is cynomosaic research group in the USA and even in Europe and in Korea, and New Zealand and Australia. So I'm also very active with other research team to get those kind of data. We have very molecular biology. So yeah, it's a good chance to collaborate with them also.
And then you have to put one dip in there.
Yes, right.
Yeah,
Yes,
right.
right.
Yeah.
I'll see you next time.
Yeah.
Tomorrow. From tomorrow, I put it here. Okay. I'm sorry, I had to talk about very difficult molecular biology. So in the future, maybe all of your students and all of your guys should understand this one. Study hard and get the experience in the overseas. Maybe they can do. Every student can do.
Yeah.
Even me also study home is very low level.
Is it possible for our students to continue the master study under your supervision?
Of course,
With a full scholarship? Full scholarship?
Oke, Pak. Lalu carikan. Oh,
Yeah.
yes. Okay, thank you. Thank you for your attention.
Thank you very interesting subject about the mechanism biology interaction from the algae living. Yeah. So from the audience, any question? Yeah, because it's very deep one.
Yeah.
What is look like? It's a food or not?
It's okay. That we focus on the deep molecular biology, or we can focus on the genetic biology. Every question is from genetic biology.
I have a question, Professor Han. Can you back to the previous slide? Previous. Your sequencing. What is this? Yes.
Okay. So this is the sequence, amino acid sequence from the PVDP to the PCDVP2.
What is the PPDDP and PCDDP?
Okay, the PVDP is plasmodium pyruvate of defined protein. And
Is that gene?
it's a gene name is EVP. Yes. And I just compare because every species have different sequence, but some part is conserved where some part is repeated. So just compare, and this red bar indicates that this all changes are very conserved, all conserved.
Is that amino acids or nucleotides?
It's an amino acid sequence.
How did you get the data that one?
Yes. The malaria, in malaria resistance, we have on website, Plasmodium. They already upload all of the malaria sequence. So also we can get reference sequence from the Plasmodium website. This is like NCBI, but only specific with malaria. So from that, I got this result. But actually, the Plasmodium sequence not used yet. Yeah. I got from my brother. They already finished posting.
Any from Zoom, we can see the person from in April 30. We know that Plasmodium falciparum, TIFAC, and the other Plasmodium infected by mosquito. Yeah, after 10 days, until to 4 weeks. And yeah, I think it's about the treatment to malaria patient. Yeah.
So,
Yeah, so this is about the cerebral malaria gene. So for all the species of the Plasmodium, including Falciparum, Camarx, Ovale, Malaria, Nullesi, the symptoms appear usually after 10 days or even 4 weeks until they got very severe malaria symptoms like hypoglycemic or even malaria cerebral. So she asked about the treatment methods, about how to prevent from the relapse from these patients. Yeah, from the relapse cases.
The relapse can occur in only IBANs and ovarian, not in particular. Particular has no haplotype stage. So after patient symptoms appear, the physician give chloroquine or artemisinin. Actually, the WHO they recommend to use artemisinin-based combination therapy. Not only one drug, because the chloroquine is very cheap drug. So many countries just use chloroquine, and nowadays this chloroquine lies the drug resistance where's that? Maybe you.
Chloroquine is resistant to cure to infection.
Yes.
Yeah.
So this is the map of the chloroquine resistance. Yes. From the 1057, they discovered chloroquine resistance, and they are spreading all over the world, not only Parasites, but also Valva also. The major model species is Parasites and Valva. So after that, WHO recommended to use artemisinin rather than chloroquine, but still, other developed countries they don't have money, so they still use chloroquine. That is the problem. Even we give a chloroquine as a drug, patient cannot cure. That is the most serious problem now. And another problem is artemisinin also starting to appear the drug resistance. The next drug target, we don't have. We don't have the next drug. That is most problem. So many big company and many researchers, they're trying to find a new drug. So the basically the treatment, some countries still use chloroquine as a drug, and some countries use magnesium. Based on the WHO support, support the country. And the dormant stage, the liver stage of the parasites, we can kill by pre-marking. We get the vivax and virus. But the important thing is pre-marking we cannot use to the pregnant woman. That is yes. Yeah, but actually, I think the pre-marking has no proof that the pregnancy woman is harmful or not. We have no proof. But there is no information, that is why we just told them don't use pregnancy.
So I have a question first. How we can know the drug resistance using the sequencing technology, or if our students want to do the research about the insecticides resistance, how we start the laboratory investigation phase with the sequencing. What the sample and how we collect the sample, or how we analyze the samples like that. Yeah, it's about the insecticides resistant and also the drug resistant study.
Okay. In case of the malaria,
Yes.
after we draw the blood from the patient, we can extract genomic DNA from the patient. And the whole genomic DNA also includes malaria genomic DNA also. So from that, we have several marker genes to identify the drug resistance. For example, chloroquine resistance gene marker, we use MDI1, but CI4, something like this gene. This is gene name. We just sequencing, make a PCR and sequencing and check the one by one the point mutation. If the test point has point mutation, we conclude that this parasite has chloroquine resistance. And also, the artemisinin also has marker gene called K13, that is gene name. Also, in that gene have a point mutation in specific site. We conclude that this parasite has artemisinin resistance. Also, we use that combination therapy with other drugs, such as networking and other drugs. Also has a different gene marker. So PCR can marker gene and checking the sequence. And if there is some mutation, we conclude that these parasites have a mutation in that drug. Yes.
How about then insecticide resistant
From the mosquito.
from the mosquito?
From the mosquito.
Yeah.
Okay. I don't know, in Indonesia using which insecticide. In Korea, we use the plasmodium in that time, we also collect the mosquito. Sometimes we using the biosay.
Yeah,
Biosay.
first,
Yeah. Yeah. And then the survivors, we collecting the biosay. So there, some alive samples we collect and in isolation and easily.
yeah. So that we have done by biochemistry, biochemical site using PVC bottle and
Yes,
also
this bottle,
yeah and the paper on the WHO. Yeah, and then we continue by molecular analysis to know there is mutation DNA after this scan. Yeah, but the result, the last research from us, we cannot find the mutation from the sampling of DNA. And then we conclude that any pesticide, insecticide can be used in the area of our research. Yeah, central Java. I don't know why. Because we use insecticide in several years ago. Yeah, but we cannot find the what is it, the resistance status of mosquito after we collect it from the area.
Okay, which
Yeah.
which species you collect?
From the field, yeah, indoor, and also outdoor. Yeah.
Indoor.
Yeah, and any species of vector that we suggest the vector from that area, such as Balabacensis, mosquito, Anopheles balabacensis, maculatus, and Algus. Yeah, but we cannot find the mutation. Maybe I just think, oh, it can be. It can be immediate like that. So because if you know about the implementation insecticide training program, I think it's very long time use that insecticide.
That is what we have to talk about. That
Yeah,
is better. This
yeah,
progressive.
something yeah, yeah, because it's still discussed about the molecular. Yeah, there is no any question
Lagi di chatroom.
on this side. Yeah,
From the
oh, you can look, you can check here.
bahasa. Yeah, you can answer the questions.
Selamat siang. Bertanya.
The main factor, yeah, the main factor cause why malaria is difficult to eliminate. Yeah,
Yes.
especially in endemic area, like in Indonesia and then the other countries.
Yes.
Yeah.
Yes. The malaria elimination is we have to think about many factors. Not only human, also bacteria, mosquito.
Yeah.
The same also monkey. The suicide though, we have to think about deeply. So if the malaria patient or like in this area, easy to reduce the patient the treatment to the treatment. The patient recovers soon. But if they remain weak, we cannot control this malaria spreading there. Even in Korea, we say the previously just 10 or 20 years ago, annually the malaria patient for more than 3,000 people. But nowadays, just with about 500, less than 500 called annually. And every year, if called every 300, we cannot reduce this one. Even the system is wrong. The diagnosis rate is high, we cannot reduce. So I don't know exactly what we are missing now. But we have to change the, even in Korea also, we need to change the policy to treat the malaria patient. Because now one of my students from Tanzania, now he like Tanzania and he collected the Tanzania patients. Actually, they don't know their patients. They are the asymptomatic cases. My students just go to village and visit their house and just take some blood and check the parasite. There it is. There is the parasite. But they are never go to hospital. Even they have no symptoms. Even the infection rate is very high. So one village we calculate that 40% people get malaria infection, 40% in one village. But they are not went to the hospital. Never. They have no fever. They have no specific symptom. So they are just like silence carrier. So they are not went to the hospital. They don't have any symptoms. So the clinician also not give any drug. So think that is there, right? Or the patient, but they don't get the patient. So if the high prevalence area, we should have some asymptomatic cases also. Okay. The malaria is not always going to the severe symptom. Some guys have no symptoms. So they are silent carrier. So still we don't know what is the factor of the asymptomatic case. But anyway, we test. Even in Indonesia, you should have some asymptomatic case. So they are just high in the community and they carry parasites. Even they don't know. So I thought that even in Korea was the same. That if the patient has symptoms, they go to the hospital and take a medication. But if there are no symptoms, they don't need to go to the hospital. So they just live and they will carry. So this is the situation of malaria elimination. So conclusion is we can reduce the malaria case, but the elimination is different word.
Yeah.
Okay?
Yeah. Like what is the malaria control?
Yes.
Yeah, it makes my friend from the malaria program and get headache.
Now even in Korea, cases is just the same.
Yeah.
We will learn the most clear. And North Koreans always play.
Yeah, that is very interesting because North Korea also has a malaria patient, and South Korea also has. Usually, the North Korea, we calculate 10 times more than South Korea. So North Korea always blames South Korea. The malaria came from the South Korea. But in South Korea, government always blames North Korea. Hey, the malaria case is much higher than South Korea. So the malaria case, the parasites came from the North Korea. Was fighting each other like this. Because our in Korea situation, the malaria patient, almost patients just living in this old area, DMG. The important thing is this DMG, we cannot control most people. Nobody can affect it. That is why the beta is going out really in front of beta really there. But people do not affect it. Always fighting each other.
Yeah, because the end of the time, yeah, thank you. And let me give applause. Thank you very much, yeah, for sharing about the malaria. And we collaborate with the research. Yeah, feedback to MC. Thank you. Okay, thank you very much to Dr. Prasan, Dr. Yud, and also Dr. Choi for today's material. Also, thank you very much for Dr. Matini as our today's moderator, Dr. Kauji, and also to will be Dr. Mika. Thank you very much. Amin. Thank you very much. We would like to apologize if there are any mistakes from us, from the committee. And thank you. Have a nice day. Wassalamualaikum warahmatullahi wabarakatuh.
Yeah.
Bisa